Well, not the smoothest start today. Sorry for the late start, everyone. Feels like time just crept up on us, right? Time seriously flies in this podcast.
Honestly, I barely noticed how fast these weeks zipped by. It's wild to think we're already halfway through this series.
Assessments S are coming up on soon, so keep an eye out for that.
Perfect timing. I actually appreciate having some understanding assessments lined up after podcasts. Makes it easier to connect the dots while things are fresh.
Speaking of connecting dots, here's how we'll break down today. We'll start with defining computer vision, glance at its history, and wrap with some conclusions. I'll also upload today's PDF after class.
That's super helpful outlines. Keep me from getting lost when the topics bounce around. So, we're starting at the very basics before zooming out to big picture AI trends?
Exactly. We'll clarify the foundational ideas before diving into where computer vision fits into the broader AI revolution. And yeah, lots of stops along the way, but I promise it'll make sense once we tie it all together.
Love a roadmap. Sometimes it's the only way I don't get overwhelmed with all this technical jargon.
So, quick question for you. What pops into your head when you hear computer vision?
Honestly, I picture a robot scanning a photo and somehow figuring out what's in it, like counting how many plates or screws are lying around in a messy workshop.
That's actually spot on. Computer vision is all about teaching computers to interpret images the way we do, identifying objects, textures, and sometimes even making sense of entire scenes.
Wild, considering how natural it feels for us. But for a computer, that's a mountain of math and pattern recognition.
You know, not all computer vision is created equal. There are 3 levels: low, mid, and high. Let's untangle what each level actually does.
I'm guessing the low level is the grunt work like basic image cleanup before anything fancy happens?
Exactly. Low-level vision handles simple tasks like enhancing contrast or blurring images. At this stage, the computer still needs a human to make decisions based on the result.
So, it's like organizing the puzzle pieces, but not actually solving the puzzle yet.
Right, and then comes mid-level vision. Here, computers begin to extract symbolic info, like recognizing shapes or plotting basic graphs about objects in an image.
That's where things start to get interesting. Computers aren't just cleaning up, they're picking out features or relationships, like drawing circles around screws and noting their size.
Exactly. Still, the output needs human interpretation. But now we're getting data alongside the visuals. It's a step up from just tweaking pixels.
So, the computer is basically handing us clues, but not the full solution yet.
And here's where things get really cool high-level vision. This is where AI jumps in, aiming for true image understanding. The computer can classify, identify, and even locate objects all by itself.
That's the stuff that powers self-driving cars, right? The car has to know what it's seeing, where things are, and how close they are, all without a human telling it.
Exactly. High-level vision is where the magic happens, letting machines really see and act on what they observe. That's why AI is such a game-changer here.
It almost feels like science fiction, but the applications are everywhere: healthcare, transportation, even just unlocking your phone.
Funny you mention image analysis. Let's talk about a technique at the heart of all this: convolution. Ever wonder how a computer picks out tiny details, like a dental implant in an X-ray?
I always picture the computer just zooming in, but I'm guessing there's a ton of math behind it. How does convolution actually work?
Picture sliding a small image, like a template, over a bigger one, and doing calculations at every step. You get a series of numbers that tell you where the features match up, kind of like scanning for hidden patterns.
So it's like playing Where's Waldo, but with math instead of your eyes. That explains how AI spots tumors in scans so quickly.
Actually, I love showing this with a quick demo. Imagine 6 people lining up, sliding past each other and shaking hands every time they overlap. Each handshake represents a calculation, just like a computer does during convolution.
That's such a good way to picture it. So every handshake is a data point, and the computer keeps moving, comparing and collecting info as it goes. Makes the math feel a lot less intimidating.
Exactly, and it's this constant sliding, comparing, and number crunching that lets computers recognize features, whether it's for medical images or sorting your photo library.
Thanks for breaking that down. I'll never look at handshakes the same way again.
Let's step back for a second. When people call this the AI revolution, what does that actually mean? We've had a few major revolutions before, right?
Totally. If you think about it, agriculture changed how we fed ourselves. Industrialization replaced our muscles, and healthcare doubled our lifespans. Now, AI is changing how we think and work.
Exactly. And convolutional neural networks, those layered parallel systems, are at the center of this fourth revolution. They're reshaping industries and creating challenges, especially around jobs and ethics.
It's both exciting and a little unsettling. The potential is massive, but the social impact is still unfolding.
What surprised me most is how much these AI breakthroughs depended on data, especially from projects like ImageNet and WordNet. Ever heard about them?
Yeah, a bit. ImageNet's like a gigantic labeled photo library for training AI, right? And WordNet does something similar for language and word relationships.
Exactly. ImageNet has millions of labeled images, like a visual dictionary for machines. Without these datasets, training and benchmarking AI models would be nearly impossible.
It's wild to think how much work went into simply labeling photos and words, just to give computers something to learn from.
Last week, we got stuck on why some AI models succeed and others flop. Honestly, it often comes down to the data. ImageNet's huge, open-source library let researchers train and test their models more rigorously than ever before.
That makes sense. With tons of labeled images, you can really push a model to its limits and see how well it generalizes to new pictures. Plus, everyone uses it as a benchmark.
Exactly. And WordNet plays a similar role for language-based AI. These open datasets didn't just speed up progress, they made it possible for anyone to innovate, not just big tech companies.
Access is huge. Without it, so much talent and creativity would be wasted.
Let's talk pioneers. Yann LeCun was one of the first to make convolutional networks work, even when almost no one believed in them.
I love stories like that. He created LeCun, right? The system that read handwritten zip codes for the U.S. Postal Service. Talk about practical impact.
Exactly. LeCun could scan thousands of handwritten numbers and sort mail automatically. It was proof that neural networks weren't just academic, they could actually solve real-world problems.
And to think, it all started with basic image pattern recognition. That foundation set the stage for so many things. Smartphones, Face ID, you name it.
You know, LeCun's story is such a reminder about persistence. Even during AI winters, when funding dried up and nobody cared, he and a few others kept working on these models.
It's kind of inspiring. Sometimes breakthroughs happen because someone refuses to give up, even when everyone else has moved on. Research needs patience as much as brains.
Exactly. The groundwork they laid during tough times ended up powering today's AI boom. Makes you realize the value of investing in research for the long haul.
And who knows, today's out-of-favor idea could be tomorrow's world-changing technology.
Switching gears, let's dig into how ImageNet actually came together. The founder, Fei-Fei, faced a mountain of unlabeled images and had to find a way to tag millions of them quickly.
I heard she used Amazon's Mechanical Turk to crowdsource the labeling, right? That's so clever, turning a huge problem into a community effort.
Exactly. By crowdsourcing, she got labels for over 14 million images, giving AI researchers the essential fuel they needed. It's a perfect example of how creative solutions can accelerate a whole field.
Makes you wonder what future breakthroughs will be possible as data keeps growing and more people get involved in building these resources.